This is the layout of a proof. We've done a few in the last few videos, and this one and number 44 are going to be done indirectly. This is the parallel lines proof. So let's take a step back and see what we have. We've got our drawing above our proof table, as we should. We've got our proof table with our statements on the left and our reasons on the right. We have our given. We have our thing we're trying to prove. And because we're doing it indirectly, we have an indirect proof list of possibilities. Okay? So let's get a closer look at the drawing. The drawing is essentially the blue and green line and the orange one. This dotted one is added later on to try to prove our point. So let's see what we've got here. Blue and green are parallel with the orange one bisecting them perpendicularly like that. Okay? So the given is that line L and M are parallel. That's given. Okay? They're telling us that. So we put that into our statement. Okay? We have to prove that the measure of angles ACB, the blue through C to orange one, right here, it would be angle 1, the pink, question mark. We have to prove that it's equal to 4. Okay? So, we're going to do it indirectly. Now, if you remember, in indirect proof, you try to prove something wrong to try to prove it right. Okay? You accuse somebody of doing something to prove that they didn't do it. Sounds silly, but that's the way indirect reasoning works. Okay? So, here's our indirect proof list of possibilities. The measure of angle ACB, number 1 with the pink question mark, is not equal to the measure of 4. Okay? We're supposed to be trying to prove that it's true. We're going to prove it's not true. We're going to assume that it's true that it's not true. Okay? Our second indirect proof is that the measure of ACB is equal to angle 4. Okay? So, as I said, we've got our parallel lines are given. And so the next thing we're going to do is we're going to plug in the pink indirect proof number 1 right here, that the measure of ACB is not equal to 4, that the pink question mark is not equal to 4. Okay? So, here's what happens. If this assumption is true, then another line can be drawn through point C so that alternate interior angles are equal, are congruent. Okay? So, what it means is, if it's true, then another line, this dotted line, or any line that goes through C, can be drawn through C so that all the alternate interior angles are equal, but they wouldn't be. If you drew another line through C, it would make these interior angles not equal. This one is cutting 2 in half. So it wouldn't be equal to 1, 3, or 4. Okay? So, now we're going to try number 2, that it is equal. Okay? In the number 1, saying it wasn't true, if it was true, and it wasn't equal to 4, then it violates, negates, or proves wrong the given. Because one and only one line can be drawn through point C and be parallel to line M. So, this is what it means. If this number 1 is true, that it's not equal, then it proves that number 1, the given, is wrong. Because only one line can go through a point on C and still be parallel to the green one. Doesn't matter where you draw another dotted line. It has to go where the blue one is, otherwise it won't be parallel to the green one. And they told us it was parallel. So that proves that the measure is equal to 4 because of alternate interior angles. Okay? The assumption that the measure of ACB equals the measure of angle 4 must therefore be true. So, indirect reasoning tries to prove that something is wrong to prove it right. If you were accused of stealing someone's cell phone from the library and 20 people knew you were in the cafeteria, your lawyer would say, I'm going to prove he stole it from the library, and he wouldn't be able to, no matter how hard he tried. Or even the person accusing you, the prosecutor, wouldn't be able to prove that you were in the library because so many witnesses would say you were in the cafeteria. Now, the opposite would be to prove you were innocent, they would prove you were in the cafeteria. But that's not the way indirect reasoning works. They try to prove that you were in the library to prove that you didn't do it. Okay? Very confusing. My advice is on all of these proofs, going back several videos, that you should probably have a geometry notebook that you write these proofs and drawings in them and keep them, because they'll come up as homework or as assignments, and you'll be able to use these as your guide to do that homework or that assignment. They may even come up on tests. So if you know these, or at least have a rough idea on how to do them, then you'll get a better grade and you'll pass. So this is the layout of a proof for a parallel lines proof that is proven indirectly. In our next video, we're going to be doing if-then statements. Those are conditional statements, and we'll be doing proofs for conditional statements.